Okay, for our second coordinate geometry proof example, we're going to prove the mid-segment theorem, which we have already proved before. Does anyone remember what the mid-segment theorem says? Shiven?
It proves like the mid-segment is parallel to its third side.
Okay, so if we have any triangle and we find two midpoints, we draw the mid-segment. Shiven says that that segment should be parallel to the third side. So if we name our triangle ABC, for example, we call these points D and E, then we'd be trying to prove that DE is parallel to AC. Okay, and somebody else, what's the other half of the mid-segment theorem? Shiven has half of it. Okay, Tanya? That's right. So the other thing we're going to prove is that DE, the length of DE is half the length of AC. Okay, so those are the two things that we're going to prove. And we're going to prove that by setting it up on a coordinate system. And so, again, we want this to represent any possible triangle. So if we call this A, B, and C, or actually I named it the other way in the other diagram, so let's call this B and C. And then we're going to have midpoints D and E to get our mid-segment. Okay. Now remember, we can name the coordinates anything that we want. Now we know that point C, since it's at the origin, has to be 0, 0. Any suggestions on how we should name point B? You can peek at our last proof. We could do A0, but are we going to find midpoints? So yeah, A0 would work, but it would be better if we did 2A0 because that way it'll ensure that we don't have fractions in any of our expressions. Okay, now point A is floating out in space. It's not on an axis, so we don't know the x coordinate or the y coordinate, so we can use any letters we want for those. So for example, I could call this 2b and 2c. Okay, so that allows us to move point A around anywhere in our coordinate plane, because we could let B could be any positive or negative number, C could be any positive or negative number. So that ensures that we are representing any possible triangle that we could create. Okay, so as A, B, and C change, the shape of this triangle changes as well. Okay, now using the midpoint formula, I can get the coordinates for point D by doing the average of the x coordinates, 2a plus 2b divided by 2, and the average of the y coordinates, 0 plus 2c divided by 2. And if I simplify that, that is just going to be a plus b, comma, c. Okay, in your groups, I'd like you to go ahead and see if you can find the coordinates for point C, again using the midpoint formula. Okay, so the coordinates for point E, if we take the average of the x coordinates for this, that would be 0 plus 2a divided by 2, which just becomes a. And the average of the y coordinates for the y coordinate would be 0 plus 0 divided by 2, so we just get 0. So the coordinates for point E are A, 0. Okay, now we're going to try to prove these two things. Okay, so to prove that lines are parallel, we need to use slopes. So the slope of AC equals, if we look at the coordinates, we can do the rise over run. Slope is always rise over run. And so our rise is the difference in the y values. So that's 2c minus 0 over the run is the difference in the x coordinates, 2b minus 0. And so we get 2c over 2b, which is just c over b. The slope of DE is same idea. If we take the difference in the x coordinates, difference in the y coordinates first. So that would be c minus 0 is the difference in the y coordinates. The difference in the x coordinates is a plus b minus a. And so we just get c over b. And since we have the same slope, that indicates that DE must be parallel to AC since they have the same slope. So we've done the first part of the proof. Now we need to also prove that the length of DE is half the length of AC. And we can find the length of a segment using the distance formula. So the length of DE is the difference in the x coordinates. So a plus b minus a squared. And the difference in the y coordinates, c minus 0 squared. And so then that becomes b squared plus c squared. Don't make this mistake. That is not b plus c. We just want to leave it like this. The square root of a squared of b squared plus c squared is not b plus c. You can't do that. You can see an example, like if you did 3 squared plus 4 squared, that is not 3 plus 4, because if we do 3 squared, we get 9 plus 16. That's the square root of 25, which we know is 5, but 3 plus 4 is 7. Those are not equal. So it's not correct to take the square root of each of these individually. You have to add them before you take the square root. So this is not correct. Don't make that mistake of thinking that the square root of b plus c, the square root of b squared plus c squared is equal to b plus c, because it's the only time that would be true is if b or c was 0. Then we can do the same thing for the length of DE. Sorry, we did DE. We need the length of AC. So the length of AC, using the distance formula, if we do the difference in the x coordinates, 2b minus 0 squared, and the difference in the y coordinates, 2c minus 0 squared, we get 4b squared plus 4c squared, because we have 2b times 2b, which is 4b squared, and 2c times 2c, which is 4c squared. And then if we factor out a 4, that's 4 parentheses b squared plus c squared. And the square root of 4, 2. So it's 2 times the square root of b squared plus c squared. Compare that answer to that answer. Okay, and we see that AC is twice as big as DE. So DE is exactly half of AC. And we've proven the second part. So we proved the parallel. We proved that the midsegment is parallel here. And we proved that DE is half the length of AC by using the distance formula. So anytime you're trying to do something with slopes, with parallel lines, you want to use slopes. And anytime you're trying to show that lengths are the same, you want to use the distance formula.